wrong with you? I love math.
Alright, Annalie, what do you know about a full rotation of a circle in radians? Do you remember a half circle? Everyone talk to your partner in 5 seconds. Annalie, did you get it? A full circle is 2 pi. So, if you don't go anywhere, that's 0 radians. And if you do a full rotation, the same position is actually 2 pi. So 0 and 2 pi are actually coterminal angles because they end up in the same position. Okay? Alright. Class, how much is a half of a circle then? Pi. It's half of that, right? Here is pi. Now let's think about this. You already know it. Pi is approximately what number? Okay, so now we call that pi is equal to 3.14 radians. Class, what's half of a pi? Just think of a pie, tin can pie at holidays. What's half of a pi? Half. So we just call that pi over 2. And if you put that in your calculator, you get 1.57. Okay, so let's think of money, right? You've got $2, 2 pies. Half of $2 is $1. $1, 1 pi. Half of a dollar is 1/2 of a dollar, right? There's like a 1 right there. Okay, so if you have, let's think money. If you have half of a dollar plus $1, what do you have? You have $1.50, but we don't call it $1.50. We call it 3/2 of a dollar. 3/2. Think about that, right? What's half of a dollar? 50 cents, and you have 3 of those. You can call it 3/2. So this is really 3/2. So you can think of this one as 2 pi divided by 2. So you can actually count. Watch. Let me try to show this to you. 0 pi over 2. 1 pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2. Do you see that? And now what I've basically done at the quadrants, they call these quadrantal angles, I've basically shown you what they are in radians. Okay. Now let's try to draw this one in our picture, because it says draw the given angle in standard position. So put your finger at standard position. That's what we learned yesterday. It's right there. That's where your starting or your initial side is. Okay. Now we need to get 4 pi. Well, we have some bad news. Are these fractions equivalent? No. Why would they do that to you? So if I multiply to get equivalent fractions, 2 over 2, class, this becomes what? 2 pi over 4. 2 pi over 4. I just multiply top and bottom by 1, and you get the same number. Okay? If I do that over here, what do you get? 4 pi over 4. This quadrant over here is 4 pi over 4. How about this one? 6 pi over 4. And then this one's going to be what? 8 pi over 4. It's kind of weird, but I don't know. If you do the same thing over here for this one, you get what? 0 pi over 4. So all I did was double all of my quadrantal angles so that I have a common denominator, 4. I count 0, pi over 4, 2 pi over 4, 4 pi over 4, 6 pi over 4, 8 pi over 4. Put your finger where do you think 5 pi over 4 is? Well, 5 pi over 4 is between 4 and 6. So my angle is actually going to be over here. So my terminal side is going to be this direction. So the angle of 5 pi over 4 is from the standard or initial side all the way over here. Now, that's in radians, right? Let's just help you get some number sense, because some students are like, Mr. Rank, I have no idea what 5 pi over 4 is, right? And I actually saw a student do this yesterday. Partner B tell partner A, what do you know about pi, or its equivalent in degrees? Ready, set, go. Class pi is equivalent to how many degrees? 180. So think about this. Look at this. I'm just converting it. This is one way of converting from degrees or radians to degrees, just to give you some number sense. Okay? 5 times 180 divided by 4. Oh, it erased it, but it said 225. This is really 225 degrees. Now, I want to caution you because I saw a student do this yesterday, and all the students I've been teaching over the years, they kind of do this at first, right? You're not familiar, right? So I want you to, when you're working with radians, I want you to work with fractions. What do I want, class?
Fractions.
No, you're not going to like it, and I know what you're going to do. You're going to run, and you're going to go back to your friend, degrees. And you're going to try to use the awesome proportion. You work it in degrees, you work on it, and then you go back. Okay? So my analogy is like, I'm trying to think of an analogy. You wear, I don't know, I wear house clothes, right? They're clean, they haven't touched anything outside. And when I go outside, then I change into like these outside clothes, right? I'm working in the garden, all my pants get dirty, right? Grass stains, everything like that. When you go back inside the house, do you just like walk around and roll in your bed with all the dirt and weeds? No, I change back into my clean clothes. Now that's redundant, right? You're like, oh man, that's a lot of laundry. That's a lot of clothes you're wearing, right? So why not just wear my clean clothes? If I'm not going to wear them again, I'll just wear them dirty, and then I take a shower. Okay? Be dirty. Kind of. I don't know. I don't know if that made sense. But what I'm trying to tell you is don't go from radians to degrees and then convert back into radians. It's a lot of work, isn't it? Do you think about that? So that's what I was trying to point out. Our first time going through radians. Alright, we're supposed to find where is 2 pi over 3. We said if we find your common denominator, it's going to be 6. I made an equivalent fraction of 4 pi over 6. Let's put that in color. Now let's get some equivalent fractions. Why did we choose 6? Well, what number am I going to multiply by? 3 over 3. So you're really multiplying each of these by 1. Everyone say multiply by 1. 3 over 3 is equivalent to 1. So if you multiply across, what do you get? 3 pi over 6. Do it over here. See how I made it a fraction? I'm going to multiply by 3. What do you get? 3 pi over... Whoops, what happened? Uh-oh. We can't do 3, right? So I'm going to have to multiply by what? 6. So this is 6 pi over 6. This one I'm going to have to multiply by what? 3 over 3, which is 9 pi over 6. And then 2 pi over 1, we're going to have to multiply by what? 3 or 6? 6. So that becomes 12 pi over 6. Do you see how it's counting there?
So you can change it.
You can change it. And that one's going to be 0. So 0, 3, 6, 9, 12. See it? Put your finger where 4 is going to be. Between 3 and 6, closer to 3. So our angle is going to be somewhere in quadrant 2. So if this was my initial at standard position, my angle of 4 pi over 6 or 2 pi over 3, that's my angle. It's going to end up in quadrant 2.
I love math.